Hey, are you ready to go with your deductive geometry practice test? Have that list of circle theorems alongside. You're allowed those. There's a lot of new ones there, so check them out. Let's have a look at this test now. I'm going to go through stages here. Question 1, as we can see, consists of 9 parts and about 2 marks each. You must give a reason for deductions you make. So I'll show you all the questions. Then you can scroll back and go through at your own rate then. Okay, so there's the first question. Come down. There's question 2. I'm going to write the solutions in after we've been through this and after you've paused it and had a go. And question 3. Question 4. Question 5. And the rest of question 5 there. And question 6. And the rest of question 6 there. Okay, so what I want you to do is to rewind the presentation now and pause it as you go through. I'm going to do each question. It should take you about an hour to do these. I'm going to go back now, so rewind the presentation, go through and pause it. Now I'm going to go back and go through all the solutions. So later on, when you've finished, go back and mark your work. Right, good luck. Enjoy yourself. See you with the solutions. Here we are. Are you ready for the solutions now? I'm going to write them in for you. Let's have a look at the first one part A here. The first thing that I notice is these equal sides here. Therefore, what we might say is alpha equals 40 degrees, isos triangle. Okay, therefore, what can we say? Beta in there, beta is 180, take 2 lots of 40, take 80, sum angles of a triangle. So beta is 100 degrees. Therefore, x is 100 degrees. Vertically opposite. Okay, so a lot of work there. Probably 3 marks for that one. 1 for each of the reasons there. Well, the angle and the reason. So 1, 2 and 3. So you could mark that out of 3. Let's look at the next one now. First thing we might notice there is that they are equal. Therefore, this triangle is isosceles. And you might say alpha here is 70 degrees. Sum angles straight line, and therefore what can you say? This one here, let's call that alpha 2. Alpha 2 is 70 degrees, isosceles triangle. Therefore x is 40 degrees, isn't it? Yep. Sum angles of a triangle. Now you'll set your work out a bit broader than that, bigger spacing. I haven't got much room here. So you get the idea. Remember the strategy is take one piece of information, see what you can do with it, make a deduction, give a reason in the brackets, take the next piece of information and try to work towards the unknown. Trapping it in a triangle if you like, because sum of angles of a triangle is quite a common strategy here, or theorem to use at the end. This one's going to start and end with that, isn't it? We're just going to say all of these angles have to add up to 180. Okay, sum angles of a triangle. Must put the reason in brackets, sum angles of a triangle. Therefore, a little bit of algebra. X plus x plus x, take 20, collecting the x's up, take 10, equals 180, so 3x, take 30 is 180, add 30 to both sides, 3x equals 210, so x is 70 degrees. You don't need to give reasons for these algebraic steps. So probably only 2 for that one, 1 for that and 1 for the answer with reasonings. Oh, sorry, I missed it out over here. 1 for that, 1 for that. No, there's 3 reasons. I'll give you 3 marks there. So far, it's out of 8, this question. Okay, come over here to part D. What do we notice? Oh, look at all this. That's a parallelogram. Opposite angles of a parallelogram are equal. So, op, angles, look at this symbol, parallelogram. Parallel lines, like that, parallelogram. Okay, subtract x from both sides, you get x equals 35. Okay, so really only probably 1 for that and 1 for that, tick being 1 there. Okay, what about this one? Only 1 mark for this one because x plus 3x is 180, sum, angles, straight line. Okay, so 5x equals 180. Oh no, we'll give you 1 for that, 1 for solving it. 36 degrees, dividing by 5. Okay. All right, don't forget the reasons, because you lose a mark without the reasons. So there's 2 there. Let's look at this one. It's quite a common one. Watch this for your test. I think that's a hint. Some angles of a quadrilateral. Some angles of a quadrilateral will equal 180. Oh, I think we have to do better than that, though, don't we? Because there's a y in there. That's going to be a bit harder. So let's have a look. Here, parallel lines, forgot those, it's a trapezium, it's not just a quadrilateral. So what can we say about this angle and this one? They must add up to 180. Co-interior angles, remember that. Co-interior angles are supplementary. So let's get x first. 2x, therefore plus 5, take 5. 180, x is 90. Okay, 1 mark there, 1 mark for finding x. And now we can do the same thing this way. Y plus x take 20 is 180. Co-interior. Okay, again parallel lines, but x is 90, so y plus 90 take 20 is 180, so y plus 70 is 180, y is 180 take 70, 110. Okay, so how many marks we got for that? Got 2 up there, 1 here, so 4 for that one. Okay, we'll have to come back and total all these up in a minute. Okay, let's go down the last few parts here. G. G is a pretty busy one. What do you notice? Well, you've got a 35 over here, and these are equal. So let's say A is 35, isosceles triangle. Okay. Now, if A is 35 up here, we've got that one. Now we've got an isosceles triangle here. So we want to get into that triangle a bit. So what might we do? Let's move into that triangle by going here first. So this angle, call it D. D is 180 take 70. Some angles of a triangle. Okay, working in this triangle here. So D is 110. So we get 1 for that, 1 for that. Now, what can we say? Well, let's just rub some of this out now, just in there. So we have this angle here at 110. Don't put on your diagram until you put down a reason. Okay, now what can we say? B is 70. Some angles are a straight line, adding up to 180. And because of these two, hang on, let's just get rid of that. These two make isosceles triangle. C equals 70, isosceles triangle. Okay, base angle is isosceles triangle. So I think that's another big one, 4 marks for that one. Another smaller one here, 2x plus 30 plus x plus 50 must equal 180. Sum angles straight line. So 3x plus 80 equals 180, collecting up the x terms. 3x equals 100, and therefore x equals 33 1/3 degrees. Bit of an unusual number there. So there's one for that and one for simplifying. You lose one if you don't have a reason. Okay, now this is a quadrilateral one. This is just a straight one. No, it's not. It's a pentagon. Okay, sum of angles of a pentagon. Do you remember if it's an n-sided figure, you've got n minus 1, is it? If you've got a 4-sided figure, how many triangles in it? 3. Got a 5-sided figure, let's just watch it here, you can make up 3 triangles. So they had up to 3 triangles, that's 540. So go x plus 20 plus x plus 90 plus x plus x. All 5 angles, 1 angle, 2, 3, 4, 5. Must add up to 3 triangles, then take 2, isn't it? Sum angles pentagon. Okay. And take 2 triangles if n-sided figure. So what do we got? 1, 2, 3, 4. 4x plus 110 is 540. Okay, so there's 1 mark for that one, then 1 mark for solving this, which is be 430. X would be equal to whatever that is, 107.5 degrees. A 1 for the answer. So let's total that whole question here. Now it's getting a bit messy. Let's come up here a little bit and see how many marks we've got overall for that first question. All right. So over here we had 1, 2, 3. It's out of 3, this one. This one was also out of 3. This one was only out of 2, so up to 8 so far. This one was out of 2, 10. Excuse me. This is out of 2, that's 12. This one over here, I think we had 4 for that, out of 4, that's 16. And over here we've got out of 4, it's 20. A lot of marks for this question, probably overmarked there. This one's out of 2, that's 22. And this one's out of 2, that's 24. So mark question 1 out of 24, I think. Roughly speaking, 24. How did you go? A lot of work there. Okay. That should have taken you about 20 minutes or so. All right, let's have a look at the next one. Explain why triangles ABC and EDC are congruent. So we usually say in triangles ABC, EDC. Let's get the matchups. BC equals CD, that's given. Deductive reasoning now. Alpha 1 equals alpha 2. Easiest way to refer to them. Alternate angles, because we have those 2 parallel lines. You could put that AB parallel to ED, and we've got beta 1 equals beta 2, vertically opposite. Vert op. So we have shown it. Triangles, put them in order now. ABC is congruent with, now A actually matches with E, B is in common, C is in common, sorry, so we'll go ABC and EDC are congruent. The reason for that, angle, and corresponding sides there. Corresponding pairs of angles and sides. Can you just make sure you get that? B and D are match-ups there. Now, that's part A. Part B, I'll put part A over here. Part B, if AC equals 5 and BAC equals 37, find the length of CE. Well, if you go back from part A, let's have a look. AC equals EC. AC equals EC. Therefore, CE equals 5 centimetres, getting matchups. You must refer back here to make sure you've got the correct matchups. And part 2, the size of angle DEC. Let's look at it. DEC would be the same as BAC. So angle DEC equals the size of angle BAC. And that's given as 37 degrees. So that's the idea of congruent triangles, isn't it? If you can get matchups and show they're identical with one of the 4 rules, remember the rules, side, 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 2 sides included angle, corresponding angles on a side, and right angle triangles, hypotenuse equal on one other side. Once you've established that, you can match up the various sides. That's the importance of this line over here, getting them in order. So what are you going to be given here? You've got to put these 3 down and state them in order. Let's be generous. Let's make that out of 4. And over here, matchups, you've got to say that to get that, not just put down the numbers. You've got to say that. So it's 1 each, so that's out of 2. So this question would be out of 6. We're up to 30 marks. How are you going? You might have been pushed for time, not sure. Let's see how we go now. Prove that these triangles are congruent. AMC and BMD. So here we go in triangles AMC and DMB, let's say. So any order at the moment, we'll establish the order in a minute. We've got AM equals BM. That's given. Let's check it off there. Yep. And put the first triangle first. CM equals DM. Also given, this one and this one, and angle alpha 1 equals alpha 2, vertically opposite. So going well here. Therefore triangles, let's make them up now. AMC congruent with, now A there, AM was equal to BM. So here it's got to be BM, BM, and C was equivalent to D here then. The M was a common angle, so got to put that in the middle. Okay, get those matchups, and this was 2 sides and the included angle. So that again will give you, I might be overmarked, give you 4 for that. 1 for each of those with reasons in brackets, and 1 for the correct statement of matchups. Deduce that A, C and DB are parallel and equal in length. So from part A, what can we say? AC equals BD. AC equals BD. And also, what else can we say? Well, let's have a look at angle CAM. Angle CAM. Angle CAM equals angle, now where do we say? CAM, so that's the same as DBM. DBM. Okay, so that's DBM in here. So this is from the matchups. And these are in corresponding positions. Therefore, therefore AC will be parallel to BD, and that's what we're asked to show in part B. So 1 for that, and 1 for stating corresponding positions and equal angles. Therefore that. So really only 2 for that. Let's have a look at part C. What can be deduced about the quadrilateral? Well, what have we just shown? If you join these up, you have a quadrilateral. We've just shown that and that are parallel and also equal. So therefore, ACBD is a parallelogram, and you should give a reason. 1 pair, opposites, parallel and equal. Some abbreviation like that. So you can't just guess it, so we'll give you 2 marks for that, but you don't get the parallelogram mark from guessing, you have to have a reason. Okay, so that's a total of 8 for question 3. How are you going? Getting a few marks? Remember, get these part marks. If you can't get it all, you get 1 mark for each piece that you put down with a reason. Okay, come down to question 4. So question 4 now is similar triangles. We've got to show they are equiangular, and one is the enlargement of the other, therefore they're similar, and you've got those ratios. Let's do the same thing in triangles triangles ABC and ADE. That's a little one and the big one. What can we say? Angle A is common. Let's put that in. Let's just tidy that up. I shouldn't get too carried away there, mate. Okay, and what have we got? Angle alpha 1 equals alpha 2, and they are corresponding angles because of these parallel lines. And beta 1 equals beta 2. Well, we don't actually have to put that, do we? If we've got 2 matching angles in 2 triangles, then the third is the difference from 180, and it will be equal. Therefore, triangle ABC is similar to, let's put them in order, ADE. Got to have the match-ups of these here, C and E. They are similar, and the answer there is AAA, and then we have to find X. So we need to have 2 of those and the statement at the end. That's 3 marks. Let's have a look at the ratios now. We can say, let's tidy the diagram up. So here, BC, we should write this BC to DE, match-ups, is the same as AC to AE. Matching up AC to AE. So putting the numbers in, BC to D is X is to 6, AC is 2, AE is 5. Remember, it's the whole side AE. That's been enlarged out to that one. So multiplying both sides by 6, 12 over 5, or X is 2 2/5. Okay, so what have we got? 1 for this, 1 for correctly substituting in, 1 for the answer. So that one is out of 6, probably a few too many marks there, but let's put the detail in. Let's do the next one. In triangles PQR and TRS, something like that, what have we got? Angle Q equals angle S equals 90. So that's given to us there. What else? Alpha 1 equals alpha 2, vertically opposite, matching up there. That's all we actually have to say. Therefore, triangle PQR, let's match them up, is similar to, now S and Q match, so, and R matches, so our next triangle will be T will match with P, so T, S, R, because the Q's and the S's, the R's must match. From what we've set up here, angle, 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 we should say that's because they're equiangular. So again, we'll want 3 marks for that. 1 with a reason, 2, 3, and finding X. Let's tidy the diagram up a bit now. So where's X? X is RS, so let's look at RS. RS would be compared to RQ. So let's put it in the order. RS over RQ would equal ST in that one over QP. That's showing the match-ups coming from that order there. So RS is X over RQ is 7. ST is 2 over PQ is 5. Multiplying both sides by 7, get 14 over 5, or X is 2 4/5. 10, 4, 2 and 4/5 down there. Okay, they're getting the hang of it. So I think we'll have another 6 for that one. Yep, make that out a 6. Okay, let's look at the last one. Same process. In triangle, let's do the big one. ZUV, and ZXY. What can we say? Angle V equals angle Y equals 90. That was given. Just taking a shortcut in labelling those angles. What else have we got? Angle Z is common. So therefore, that's all that we have to do, because the third angle, by difference from 180, must be the same. So triangle ZUV is similar to, Z is common, so similar to triangle ZXY, because the V and the Y are both 90, they match up. So we've got angle, angle, angle. Again, 3 marks for that. And then let's look at our ratios. So XY is X, so XY to UV, but you should put it like this first to show from that matchup you've got the pattern. And what do you want? ZY to ZV. Remember, it's a whole side. So just think about the maths of this. In similar triangles, we say this has been stretched or enlarged out to that one, not to 5, but to 11. So let's put the numbers in. XY is X, UV is 6, and ZY is 6, and ZV is 11. So multiplying both sides by 6, 36 over 11, so X is 3 and 3/11. So 1 for the ratio, 1 for correctly subbing in, and 1 for rearranging to get the answer. So we have a total of 18 for this one. Okay, let's go down the circle theorems now. We're well underway. How are you going with your marks? Getting a few, I hope. Okay, find the value of A giving reasons. Into the circle stuff now. Okay, well, looking at A down here, we've got a bit of work to do, I think. First of all, I see the 36, and I think beta is a half of that, 18 degrees, angle at the centre theorem. Okay, so beta is 18 degrees. Now I'm into this little triangle here, and we can say, we better label this, I think, to refer to it. Triangle triangle AOB is isosceles. Y equal radii. Okay, did you see that? That's often a hidden piece of information. Squeeze that, use all the given information in a circle. If you're given the centre, just remember those equal radii. So therefore, angle OAB is another A. Okay, base angles are equal, base angles equal, isosceles triangle. Therefore, A plus 18. Whoops. Oh, I got it wrong already. 36, I halved it, I should have doubled it. 72, the angle at the centre is twice the angle at the circumference. I have the wrong one. So this is A plus 72 is 180 degrees. Some angles of a triangle. We're working hard here. 2A plus 72 equals 180. Take away the 72. 2A equals 108. Therefore A is 54 degrees. Fair bit of work there. Okay, so let's look at the marks. 1 for that, 1 for recognising with a reason the isosceles triangle, therefore getting the other base angle. 3 marks, 4 marks for reason, and I think we'll only give you 5 marks for working this out. One more mark, so that's out of 5. We'll skip on the bit at the end with the algebra. Okay, remember the strategy. Look at the information given and use it all. Okay, so what do we got here? What hits you first here? Well, the centre, and we've got a diameter. That's what hits me. Did you see it? So the diameter, I think here we can say angle beta up there. Angle beta is 90 degrees. Angle in semicircle. Okay, therefore 28 plus 90 plus A would be 180 degrees. Some popular one, isn't it? Some angles of a triangle. That's what we're trying to do. Trap that unknown into a closed triangle there, and then we can use it. So, what does this mean? A is 180, take 28, take 90, which is A is 62 degrees. Okay. Now, we want 1 mark for that, 1 mark for that. I'll give you 1 for that, for taking it away. Okay, out of 3. How are you doing? Okay, let's go to the next one here. Now, we want A here, and this is not the centre, by the way, so don't think about that. That's not the centre. You'd like it to be, but it's not. Okay, I want to use this first of all. I'm going to use this one. So I'll say in here, let's call it beta, not to confuse it with A. So beta is 41 degrees, subtended, same arc, or angle in same segment, either of those abbreviations, because both of them are sitting on this arc here. So beta is 41. And what's this one now? A plus 41 has to equal 102 degrees. That's the exterior angle of a triangle. Remember that one? If you take a triangle and you extend the side, so you go out here, the angle in there is called the exterior angle. It equals the sum of the interior opposites there. Okay, otherwise you've got to add them up, get this one, take it away, and get this one. Don't worry about that. Just go straight to that exterior angle theorem. So now what can we do? Take 41 from both sides. This is 61 degrees. Okay, so 1 for that and 1 for that. That one's out of 2. We'll come back and total all this up in a minute. Let's go down and have a look at D, E and F. Okay, it's a very busy figure over here. What have we got? We've got 240 degrees around that back angle. Okay, so let's see what we can do. This is very crowded. So what must this one in here be? That angle in there, let's call it a beta. Beta would equal 360 minus 240. Okay, some angles at a point. Okay, so beta is 120 degrees. Therefore, let's call this one over here, what can we call that? Delta maybe. So delta is 60 degrees because the angle at the centre theorem, angle at the centre. This is a bit hard to see. See this? That subtends delta there and this beta in the centre. You've got to watch that in there. Okay, now what is A? A is equal to 80 plus 60. That's that exterior angle theorem. Exterior angle theorem again. So A is 140 degrees. Because here we are, this is the exterior angle equals the sum of the interior opposites there. Hard to see that one. Okay, so let's have a look. We get 1 mark there, nothing for taking it away. 1 mark there, 1 mark there. So that one's out of 3. You must have most of the reasons there. Let's look at the next one now. I see a tangent straight away and an angle here. So I think, right, the angle between a tangent and a chord equals the angle in the alternate segment. So let's call that angle beta. Beta equals 38 degrees, alternate segment theorem. Okay, or tangent chord theorem. Tangent chord theorem. Okay, so we've got that. What's the next piece of information? Let's tidy this up a little bit here. What do we got? We've got these two sides equal here. So that means we have an isosceles triangle. So you could say beta 2 equals beta equals 38 base angles. Isosceles triangle. Maybe you could put down that these two are equal, first of all, those sides, but it's okay to recognise an isosceles triangle there. Okay, so what have we got? A plus a beta must equal 180 sum angles of a triangle. So A plus 76, 238s, 180, A is 180, take 36, which is 104 degrees. Okay, so A is 104. Let's mark it. 1 for that one for the base angles, then 1 for the rest of it out of 3. Must have most of the reasons there. Let's look at the last one. What do you notice? All tangent, tangent. Okay, that's special. And there's a radius tangent theorem that says that this angle is 90. So let's put that down. Alpha is 90 degrees, radius tangent theorem. Says that that's 90. And I think we've got the answer then, because we can say 3a all squared, the square on the hypotenuse, equals the sum of the squares on the other two sides by Pythagoras. Okay, by Pythagoras. Therefore 9a squared equals 100 plus 4a squared. Don't forget the square, the 3 and the 2, that's why I bracketed it. Subtract 4a squared from both sides. 9a squared take 4a squared is 5a squared equals 100. Divide both sides by 5, a squared is 20. And then a equals plus or minus the root of 20, but a must be a positive, it's a length, so it's root 20, since a is greater than 0. And you could go further, root of 4 by 5, which is root 4 is 2 by root 5, or just 2 root 5 centimetres. 2 root 5 centimetres. Okay, so what are we going to get for that one? First of all, 1 mark for that. 1 mark for the correct statement with Pythagoras, and then 1 mark for this, and 1 mark for correctly getting it. We'll have either this one or this one. You can have root 20 if you like. So this is out of 4. Now I think the next is another question, yep. So let's go back and just sum these up now. So what have we got? We've got 6, 10 there, 15, 18, 20. So question 5 was out of 20. Right, let's go and try and finish this off now. So I think this is the last question, isn't it? We've got 6 parts there as well. So come down, let's have a look at this. Okay, what have we got here? Well, we want x, and we've got 142 and 56. Uh-oh, here we are. We can find alpha. Alpha plus 56 is 142. That's that exterior angle of a triangle theorem. Okay, subtracting 56 from both sides. Okay, would be, what is that going to give us? 142 take 56 is 86 degrees. Okay. What are we going to get for that? Alpha equals that. Therefore, x is 86 degrees. Subtend the same arc or angle in the same segment. So 1 for that and 1 for that with reasons. That's out of 2. Okay, let's look at the next one here. We see a perpendicular there, a perpendicular from the centre bisects the chord, and we want the radius. So let's draw in what we've got here. Let's draw this little part of the triangle here. that's 3 centimetres to there. X that will be the same as x there, won't it? X centimetres, because they're all the radii. Okay, and this is 5. So we should put here L is 5. From centre. Perpendicular drawn from the centre to the chord bisects the chord. Therefore, x squared equals 3 squared plus 5 squared by Pythagoras. X squared equals 9 plus 25 or 34. X is plus or minus square root of 34. Oops, let's just go back up now. And so here, x must, I'll just stop that a minute. We'll get rid of that. So what can we say now? X will equal root 34, because x is a length and it must be greater than 0. Okay, so check that one out, a little bit of Pythagoras in there. Let's have a look at the last one, or a tangent. That's interesting because we know line from the centre to the point of contact is 90. So here refer to that as alpha. Alpha is 90 degrees. Radius tangent theorem. Radius drawn at the point of contact makes an angle of 90. Therefore, by Pythagoras, what have we got? The square on the hypotenuse, be careful here, the hypotenuse is all of that, is the sum of the squares on the other two sides. But what's this? We better put that in, L squared, this is by Pythagoras, and then we'll go 8 plus x squared equals 15 squared plus, what is that? That's another 8, because it's a radius, isn't it? L is a radius, so it should give a reason, because it's going to equal the radius there of 8. That's a little tricky, too. Let's see if we can work this out. 8 plus x squared equals these two squared, 225 plus 64. 8 plus x all squared is, what is this, 289. So square root of 289 is 17. Okay, so we should put plus or minus 17, but it's got to be positive because our distance is positive, so it's 17, length is greater than 0, therefore x is 9. So that's an interesting little problem there, where we're using Pythagoras again. Oh, we forgot to mark this last one. Let's have a look. There's 1 for this one, 1 for this, 1 for the answer. That one's out of 3. And over here now, 1 for that, 1 for setting up Pythagoras, 1 for realising that third side there was 8. 1 for getting down to here, and then 1 for the answer out of 5. So that's quite a hard one there, but see what you think. A bit of algebra coming in. Let's finish off question 6 and then do a final total. Okay, so here's the last part of question 6. We just go down a bit too far now. Hang on, we'll just get this going. So we come to here. All right, so what do you notice? We got the centre. Use that straight away. And therefore this angle here, alpha, is 90 degrees. Angle in semicircle. Angle in semicircle. Okay, because this is a diameter through the centre here. This line here through the centre is a diameter. Therefore, x plus 90 plus 48 equals 180. Sum angles of a triangle. There it is, they must all add up to 180. Therefore, x equals 180 minus the other 2 is 138. So x equals 42 degrees. Okay, so there's 1 for that, 1 for that. We're only going to give you 2. You have to do the subtraction for no marks, especially there. Let's look at the next one now. Okay, so this is similar to one we just did. This angle in here, call it alpha, is 110 degrees. Some angles at a point come to 360. That's alpha is 110, therefore x is 55. Why? Because alpha is the angle at the centre, sitting on that arc, and x is the angle at the circumference, sitting on the same arc. So this is angle at centre theorem. Okay, so we've only got 2 marks for that one. These are more going back to the basic theorems. Okay, so let's have a look now and see what we can do with this last. Okay, so in this last one, let's have a look. We've got 20 up here, up the top here. We've got the tangent radius theorem, so alpha in here will be 90 degrees, radius tangent theorem. And then with our 20, what can we say? Well, our 20 in there is going to give us an angle in here. What we can say there is that beta equals 180 minus 90 minus 20, or 70 degrees, some angles of a triangle. Beta in there at 70, and then we can say okay, so let's keep going with it. Let's get rid of that there now. Okay, so we've got that 70 for our beta. What do we notice? OA equals OC equal radii. Okay, so those two are equal. Therefore, this angle in here, angle ACO, equals beta as well, 70 degrees, base angles of an isosceles triangle. So what have we got then? Okay, so let's put some of them in here. We've got a 70 here, and let's get rid of this here. We've got another 70 there because of this isosceles triangle. Therefore, x plus 70 is 180. Some angles of a triangle. So let's just tidy this diagram up now. We're looking at this triangle now, 70 and 70. Done all that work to get those 70s, so x is 180 minus 140, so x is 40 degrees. Fair bit of work there. Let's have a look at that. So first of all, 1 mark there. 1 mark for finding that first beta, some angles of a triangle. Then 1 mark for saying that base angles there, recognise isosceles triangle with the equal radii. So that's an important point. The idea of having a diameter and a centre giving rise to a diameter and equal radii is an important extra piece of information, always available in a circle. And then the last one here is that. So that's out of 4. So what have we got? We got 8 marks. We've got 8 marks there. 13, 16, 18. So what did you get for question 6? Let's add them all up now. This is 18. This is out of 18. So let's go up and see what the next one was. So 18 there. 20, 38, 56, 64, 70, oh, that says 94 marks. I guess that would have taken you a long time. I don't know whether it actually is worth that many marks, throwing marks around there quite a bit. But if you'd like to go through again, of course, just rewind it and go to the particular question that you didn't understand. Let's just check that addition, see if I really did give you that many marks. 24, 30, 38, 56, 76, 76, 94. Yep, there are 94 marks there. All right. Okay, I hope you enjoyed that. That would have taken you considerably longer than an hour. That was meant to be an hour, but it would have taken us considerably longer. All right, more like an hour and a half probably. Good practice, and I hope that gets you ready for the actual test. Okay, good luck with that, and cheers for now.